curve has equation y equals 4 under root x. The normal to the curve at point 4, 2 meets the x-axis at P and y-axis at Q. Find the length PQ, correct to 3 significant figure. Okay, first thing we need is normal to the curve's equation. So before that, we need the gradient of the tangent. That will be found from dy by dx. Okay, so this is 4x power half. 4x power half, and when we derivate it, it becomes 4 half x. Power gets reduced by 1, so half minus 1 is minus half. Okay. Now in it, we have to substitute x is equals to 4, and that will give us gradient of the tangent. That would be 4 times 0.5 times bracket 4 power minus 0.5. That's coming out to be 1. So then the gradient of the normal, which will be negative reciprocal of this, would be -1. And equation of the normal would be in point slope form, y minus y1 is equals to mx minus x1. That is going to be y minus 2 is equals to -1, x minus 4. Now we need the coordinate of P and coordinate of Q. Okay. At P is the x-intercept where this normal cuts the x-axis. So its y is going to be 0. And similarly, Q is the y-intercept where this normal cuts the y-axis. So its x is going to be 0. So to find the coordinates of P, I'm going to substitute y is equals to 0. That gives me -2 is equals to -1, x minus 4, which gives us 2 is equals to x minus 4, which gives us x is equals to 6. So coordinates of P are 6, 0. And to find coordinates of Q, now we replace x with 0. So we have y minus 2 is equals to -1, 0 minus 4. So that gives y minus 2 is equals to 4, which gives y is equals to 6. 0, 6. Okay, so Q would be 0, 6. Okay. Find the area of the region. Okay, we're not done yet. We need the length of PQ. So now we need to apply the distance formula on these two coordinates. And we know that is square root y2 minus y1 plus x2 minus y2 minus y1 whole squared plus x2 minus x1 whole squared. So that's going to be 6 minus 0 whole squared plus 0 minus 6 whole squared. So that is square root 36 plus 36, which is square root of 72. And we have to give the answer in 3 significant figures, which would be 8.4. The decimal value is 8.48528, which becomes 8.49 in 3 significant figures. Okay, next it says find the area of the region enclosed by the curve x-axis and the line x is equals to 1 and x is equals to 4. Okay, so that is going to be integration of this curve within the limits 1 to 4. Okay, let's do this. Okay, so it's going to be 4. You can actually bring 4 out because it's just the coefficient. So I'm bringing 4 out. And I'm going to integrate x power half, which is going to be x3 upon 2, power 3 upon 2, and 3 over 2 here. And after simplification, it becomes 2 over 3, like this. And limits are 4, 1, and there's also a 4 outside. Okay. So let's substitute the value of 4 and 1. In fact, you can also bring out 2 over 3. Bring out 2 by 3, and now let's substitute 4 and 1. In x power 3 upon 2. Okay, outside I have 8 upon 3 now. Inside I have 4 power 3 upon 2 minus 1 power 3 upon 2, which is going to be, this would be 8 minus 1, which is 7. So we have 8 times 7 divided by 3, which is 56 upon 3, which is the final answer. And if we need the decimal answer, that is 18.7 in 3 significant figures.